Hi everyone, and welcome to this grade 9 mathematics lesson where we will be exploring the commutative, associative, and distributive properties. My name is Miss Donnell Phillips. Let's get started. The commutative property. Now, before I give you a definition for the commutative property, I have some examples for us to go through, just for us to compare the answers. The first one is the addition. Let's say we have to add 3 and 5. We know that 3 plus 5 gives us 8. But what if we swapped it? What if we have to add the 5 plus the 3? Would the answer remain the same? It sure will. What if we're subtracting? 5 subtract 3, we know that the answer would be 2. But if we subtract 5 from 3, would the answer still be 2? The answer would not remain the same. So if we swap the numbers when we're subtracting, the answers would not remain the same. What about multiplication? 3 times 5 would give us 15. Likewise, 5 times 3 would also give us 15. So even though we swap the numbers, the answers still remained the same. 3 divided by 5 would give us 0.6. But 5 divided by 3 would give us 1.67. So if we were to go from the top, whenever we swap numbers around when we're adding, does the answer remain the same? Yes, it does. So this is telling us that addition is commutative. What about subtraction? Since the answers were not the same when we swapped them, subtraction is not commutative. For multiplication, the answer remained the same. So multiplication is commutative. And lastly, for division, the answer did not remain the same. So division is not commutative. So the commutative law tells us that the order in which we add or multiply numbers does not matter. Even if we swap the numbers around 10 different times in 10 different ways, as long as we're adding or multiplying, the answers would not change. So for addition, you can add in any order, and for multiplication, you can multiply in any order, and the answers will not change. The associative property. What if we have to add 1, 2, and 3, but we decided to group the 2 and the 3 together? We know that from BODMAS, we would have to work whatever is in the bracket first before we could work what is outside of the bracket. So when we compute what's in the bracket first and then add a number outside, we would end up with 6. If we decide that instead of grouping the 2 and the 3, we now want to group the 1 and the 2, the answer would still be 6. So we can say that addition is associative. What about if we're subtracting? If we have 5 subtract 3 subtract 2, that answer would be 4. But if we group the 5 subtract the 3 and then subtract the 2, that answer would be 0. So we can say that subtraction is not associative. For multiplication, if we're multiplying 1, 2, and 3, but we decide to group the 2 and the 3, so we're going to multiply the 2 times 3 and then multiply it by 1, that answer would be 6. If we swap it now and we group the 1 and the 2, we multiply that first and then multiply what is outside of the bracket, that answer would still remain the same. For division, if we have 18 divided by 6 divided by 3 and the 6 and the 3 are grouped together in a bracket, then that answer when we worked it would be 9. But what if instead of grouping the 6 divided by 3, we now group the 18 divided by 6? When we work that answer would be 1. This is telling us that division is not associative. So the associative property states that the order in which we group 2 or more numbers when we add or multiply does not matter. So we could have 150 different numbers to add or multiply. It doesn't matter which one comes first. As long as we're adding or multiplying, then the answer would always remain the same. The distributive property. The distributive property states that multiplication distributes over addition and subtraction. The distributive property enables us to simplify expressions that have an expression being multiplied by a simple term. Now, we know that a mathematical expression comprises of numbers and letters, and they're separated by either an addition, a subtraction, or multiplication, or even a division sign. So whenever we have some expression that is being multiplied by another expression or by another term, then we have to use the distributive property to simplify that expression. So the general rule for the distributive property, if we have B and C being added together in one bracket and both are being multiplied by A, so we would read this as A multiplied by B plus C, we would have to distribute the term outside. So the A would have to multiply the B and the A would have to multiply the C. And then we have to add them because the B and the C are being added together. The same thing goes for subtraction. If we have B minus C and there's an A outside of the bracket that is multiplying both terms, then we have to distribute the A. So we would have A multiplied by B subtract A multiplied by C. And the A, B, and the C should always be real numbers when we're dealing with the distributive property. Example. If we have 5 multiplied by 9 minus 6, using the distributive property, how do we go about expanding this? Since the 5 is outside of the bracket, we have to multiply the 5 by the 9, and we also have to multiply the 5 by the 6. And since these two numbers are subtracting, then we would have 5 multiplied by 9 subtract 5 multiplied by 6. And 5 times 9 is 45. 5 times 6 is 30. So we now have 45 subtract 30. And when we take 30 from 45, we're left with 15. Here we have another example. But instead of subtraction, we now have addition. The two numbers in the bracket are being added. So we have 4 multiplied by 3 plus 2. The first thing we have to do is, yes, we have to distribute the 4. So the 4 would multiply the 3, and the 4 would also multiply the 2. And these answers that we get after we finish multiplying, we would have to add them together. So 4 times 3 is 12, and 4 times 2 is 8. So 12 plus 8 is 20. So when we expand 4 into 3 plus 2, and we expand it using the distributive property, the answer is 20. So to summarize all that we've learned, the first one, the commutative property of multiplication. The commutative property of multiplication states that the order in which we multiply numbers would not change the answer. So if we have A multiplied by B, that would be the same as B multiplied by A. Subtraction and division are not commutative. The associative property of addition. The associative property of addition states that the order in which we group two or more terms would not change the answer. So if we have A plus B plus C, and we decide to group the B and the C first before adding it to the A, that would be the same as if we group the A and the B and then add the C. The associative property of multiplication. The order in which we group numbers when we're multiplying would not change the answer. So if we have to multiply A, B, and C, and we decide to group the B and the C and then multiply it by the A, that answer would be the same as grouping the A and the B first and then multiplying it by the C. And lastly, the distributive property. The distributive property states that multiplication is distributed over addition and subtraction. So if we have A multiplied by B plus C, that would be the same as A multiplied by B plus A multiplied by C. This has brought us to the end of this lesson, where we explored the commutative, associative, and distributive properties. My name is Miss Donnell Phillips. See you next time.